Section 8-7, volumes of prisms and cylinders. Our lesson objectives today are to use models and a formula to find the volume of a prism, and to use models and a formula to find the volume of a cylinder. Alright, so the first thing that we need to get out of the way is the definition of volume. So volume is the space that a figure occupies. It is measured in cubic units. So that means we're going to be seeing cubic inches, cubic meters, cubic feet. So our units are going to be cubed, all right, raised to the third power. So we're going to take a look at Cavaliere's principle, Theorem 811 here, which states if two space figures have the same height and the same cross-sectional area at every level, then they have the same volume. Alright, so essentially it states that it doesn't matter if we have a right prism, if we have an oblique prism like in the middle, or we have a triangular prism like we have on the far right side, as long as the cross-sectional area, and assuming that the cross-sectional area remains constant, right? If that cross-sectional area is the same, then the prisms will have the same exact volume. Let's take a look. If I take a look at our far left prism right over here, I see that the cross-sectional area is 3 centimeters by 2 centimeters, and we can see that no matter what layer we select, it's going to be 3 centimeters by 2 centimeters. So the cross-sectional area is 3 times 2, which is 6 centimeters squared, and that looks like a very terrible, so I'm going to rewrite it here. 6 centimeters squared for the cross-sectional area here. And now we take a look at our oblique prism here, and we see that the cross-sectional area here is 3 times 2, which is also 6. So we write 6 centimeters squared. Our last prism is a triangular prism, right? Has triangles as their bases, or as its bases. So we take a look and we have a right triangle here. We can use the formula of area of a triangle, which half the base times height. So half the base here is 3, right? Half of 6 is 3. 3 times 2 is 6. So we also get 6 for the cross-sectional area. So that's 6 square centimeters. And they all have the same height. Since they all have the same height, then they will have the same exact volume. Alright, we're going to be using this principle in this lesson, and we're going to be seeing our first theorem that applies to volume. Actually, that will be our second. So this one is Theorem 812, which is volume of a prism, and it states the volume of a prism is the product of the area of the base and the height of the prism. So we have volume equals the area of the base denoted by capital B. So we're going to be using capital B again here for the area of the base times the height. Okay, so this right here is going to give us cubic units. Alright, let's take a look at some examples that make use of this formula, this concept, and we can move on. So our first example here is example 1, finding volume of a rectangular prism. Find the volume of the prism below. So we know, we're using the theorem, that the volume, the main formula in general, is volume equals the area of the base times the height. So we can see, because it told us that we're dealing with rectangular prisms, so the bases are going to be rectangles, and we can see that the area of the base, let's take that aside, we're going to see area of the base, B is going to be, right, length times width. So we have 20 times 24, and we multiply 20 times 24, we get 480. And since B is area, that's going to be 480 centimeters squared, right? Now we come over here back to volume, and we can plug that B, and B is 480. 480 times my height happens to be 10 centimeters. So I'm going to multiply that times 10. And when we multiply those, we get 4,800. Let me erase that many. Right, there you go. 4,800, and the units are still centimeters, but since we're dealing with volume, it's going to be centimeters cubed. And there we have our answer. All right, you could actually do this in one step if you like, which I'm just going to show right now. We can say this is volume is equals 20 times 24 times 10, and that still gives me the 4,800 cubic centimeters. All right, and that's volume. Part B, as usual, is yours, and I'm going to leave the diagram there because we're going to be making use of it as well. So it states, suppose the prism in example 1 is turned so that the base is 20 centimeters by 10 centimeters and the height is 24 centimeters. Explain why the volume does not change. All right, take a good look at it and see if you get the same answer and reasoning that I do. Good luck. All right, so we know that we're dealing with volume still. Volume, again, is the area of the base times height. And I'm just going to substitute here all the numbers that I need. And you'll see what happens. So we have the area of the base is going to be 20 times 10. And then the height is now 24. Now if I compare that to the volume that we had on the other one, which was 20 times 24 times 10, right? The numbers didn't change in the multiplication. Since multiplication happens to be commutative, it doesn't matter in which order I multiply. I will still get the 4,800. So why do we get the same volume, or why does it does not change? Because the commutative property, commutative property does not change the value. All right, so the commutative property does not change the value. It doesn't matter again. It doesn't matter. I have 20 times 10 times 24 is the same thing as 20 times 24 times 10. We get the same exact answer. And that's it for part B. All right, moving on to our next problem. All right, finding the volume of a triangular prism. Find the volume of a triangular prism here on the right. And we see it's a triangular prism because the bases are triangles. So we're going to be using the formula that we have, which is the volume equals the area of the base times height. So the first thing that we denote is that height is 10. So we know that h is going to be 10. And we need to find the area of our bases, right? Or one of the bases. And we know that we're dealing with an equilateral triangle because the sides over here are 8 rather. 8 here, 8 here. And if we look at the height over here is also, not the height, at this side over here is also 8. Essentially, I'm going to draw this triangle over here. It's not going to be pretty, but it will help us solve this problem. So we know that this is going to be 8, this is going to be 8, and this is going to be 8. Since it's an equilateral triangle, we know that each of those three angles are 60 degrees. I want to find out the height of this, so I'm just going to use There I have my altitude drawn here of this triangle, and since it's an altitude, it's going to be making this angle right here at 90 degrees. It's also going to bisect this side over here, making this length here 4 and this length here 4. And if this angle is 60 and I have this angle being 90, that means that this angle is 30. And now I'm going to bring one of those triangles here so we can work better. I need to know what the height is so I can calculate the area. All right. So this side here is 8. This guy here is 4. Now I could use the Pythagorean theorem, but I know that this is a 30, 60, 90 triangle. So this guy is 60. We said this guy is 30, and we have 90 over here. So if you remember, this missing side, since this is the shortest side, right? The shortest side, we know that the shortest leg, or the shortest side, the shortest leg, the longest leg is going to be the square root of 3 times the shortest leg. So this side right here is going to be 4 times the square root of 3. So now we know what our height is, which is 4 times the square root of 3. So now we calculate the area of this triangle, knowing that full well that this is just half of the big one. So whatever I get here, I need to multiply that by 2. All right, since that's the case, I'm going to take into consideration that I need to multiply by 2. So I have 2 times the formula for area of that triangle is 1/2, right, times the base, which is 4, times my height, which is 4 times the square root of 3. All right, I'm going to close that bracket here. I'm going to start cleaning this up a little bit. So it says 2 times 2, because 1/2 times 4 is 2, times 4 square roots of 3. And I actually forgot to put my 4. So it's 4 square roots of 3. Okay. And when we multiply all this, we get 16 square roots of 3. And this is going to be centimeters squared. This is just the area of that base. All this is B. Okay. Now we go back to the volume and we say, or we write rather, we have 16 square roots of 3 times my height, and the height is 10. The height is 10. So we have 10, and we multiply that, we get 160 square roots of 3. Okay, now it doesn't say here of anything about leaving this into simplest radical form or rounding to the nearest tenth or anything like so, but we're dealing with whole numbers, 10, 8, 8, and here, so we're going to approximate this. So this comes out 160 times the square root of 3 comes out to be 277.1281. So when we go ahead and round this up to the nearest whole number to match our information, then we have 277 cubic inches. And that's the volume of this prism right over here. This triangular prism is 277 cubic inches right there. All right. Moving on to part B. Part B is yours. All right. And it says, find the volume of the triangular prism here at the right. All right. Good luck with this one. All right. When doing this one, again, we're dealing with a triangular prism. Okay. So the first thing I usually do is just write the formula for volume in general form or in general terms, which is the area of the base times height. Okay, so one question that might arise is, how do I know How do I know which is the base? Well, the thing is that they actually tell you the shape of the prism, triangular prism, right? So I know that I'm looking at the triangular faces as my bases. Also, if they were not to tell you about what type of prism it is, or if you really can't figure out, just know that if I were to slice this prism, the only shape that will remain constant is the triangle. Because if I wanted to cut it in this way, none of the cross-sectional areas will be the same, right? But if I cut it alongside or parallel to the triangular face, each slice will be a triangle. So that's another way to find out what base I'm going to be using. Okay, so enough of that. We're going to calculate RB, which is the area of the base. We know that the area of the base, or it actually happens to be a triangle, it's a right triangle to be more precise. So we take the formula for a triangle, for the area of a triangle, which is 1/2 the little base, little b, times height, all right, times height of, in this case, the height of the triangle. So we substitute and we have 1/2 little b, the little base is 6, so it's 6 times the height of the triangle, which is 10. Okay, and when we multiply this, we get 1/2 times 6 is 3, and 3 times 10 is 30. So we have 30, and we're dealing with meters, so it's 30 meters squared. Now we take that 30 and we plug it into the formula for volume, and we have 30 times the height of the prism this time. The height of the prism happens to be 5. So we take the 5 and multiply it times the 30. And 30 times 5 is 150. 150. Our unit's still meters, but we're dealing now with volume. So it's going to be meters cubed or cubic meters. Okay? Either way you say it, it's accepted. All right? So that is it for this problem. Okay? All right, moving on. Moving on to our next theorem, which is the volume of a cylinder. The volume of a cylinder is the product of the area of the base and the height of the cylinder. Sounds very familiar. As a matter of fact, the formula is identical. Is volume equals area of the base times the height. However, the formula for the area of the base happens to be a circle. So now we could rewrite this as our volume is going to be the area of a circle in general terms is pi r squared times h. So we can actually use this like that, and this is how we're going to be using the volume of a cylinder, that formula right here. And we're going to take a look at this in the first example here, in example 3. All right. So find the volume of a cylinder here on the right, or the lower right, if you will. Leave your answer in terms of pi. And keep in mind, it says keep your in terms of pi. So what does that mean? That I should see the symbol pi or the pi symbol in your answer. So let's get to this. So we know that the area, or the volume rather, formula for volume is area of the base times height. So we know that the area of the base is going to be a circle, so we're looking at pi r squared times my height. Okay, so pi r squared, I'm gonna put it over here, pi r squared. So our radius is 3 centimeters. So this is going to be pi times 3 squared, and that gives me 9 pi. And that is 9 pi, and this is area, right? So it's 9 pi centimeters squared. Then we take this 9 pi and we plug it in here, right? this 9 pi. So we have 9 pi times the height, and the height happens to be 8. And we multiply 9 times pi, we get 72 pi. 72 pi, and it's going to be 72 pi. And we're dealing with centimeters. And that means the centimeters cubed, or cubic centimeters. All right? And that's it for the volume of this problem in terms of pi. All right? Now, part B is 2 parts. And before you roll your eyes, it's 2 parts, and they're actually related. So let's take a look. The cylinder at the right is oblique. Find its volume in terms of pi. That's part 1. Part 2, find its volume to the nearest tenth of a cubic meter. All right? Good luck with this one. Okay. Taking a look at the first part. Again, we're going to be using volume equals the area of the base times height. And we see that the base is a circle, and we need to use the radius. Well, they don't give us the radius, but they give us the diameter, right? So we know that the radius equals the diameter divided by 2. So the diameter is 8. So we have 8 divided by 2 equals 4. So it's 4 meters. Okay, so now that we have 4 meters, all right, so we need to calculate B. So B is going to be pi r squared. We plug in the 4 that we just found, so we have pi 4 squared, so is 4 squared, so we have 16 pi. Then we plug in the 16 pi here, we have 16 pi times our height. Our height here happens to be 16 meters, so we take, and this 16 pi happens to be 16 pi meters squared. So 16 pi times 16. And we multiply this, we get 16 times 16 gives me 256 pi. And the units are meters, but now we are dealing with volume, so it's going to be meters cubed or cubic meters. Okay, that's it for part 1. Now part 2 is very, very, very complicated, because all you have to do is take this 256 and multiply times pi and see what you get. All right, so for calculations, for me at least, you can use 3.14 as pi. Okay, I particularly just use the pi value that my calculator has, and then round it up as needed. So this one says round it to the nearest cubic meter, actually to the nearest tenth of a cubic meter. So we're gonna say here volume equals 256 times 3.14, which is the approximation of pi that we can use, and we multiply that, and that gives me 804.2 meters, and it's going to be meters cubed. All right, moving on. All right, so we have here our next term, which is a composite. Composite space figure. Space figure. It's a three-dimensional figure that is the combination of 2 or more simpler figures. We're going to take a look at our first example here, which states finding volume of a composite figure. Use a composite space figure to estimate the volume of the backpack shown here below. All right, so here we have this figure in which we could probably separate or make 2 space figures that we can calculate. Essentially, we're going to be drawing here a prism and a cylinder. But we're going to take a look at that, how that looks, in just 1 second. Alright, so now here we have the same space figure, but now we have divided it in two other figures that we can actually work with. One is a prism, and the other is half a cylinder. So to do this, all we have to do is we're going to be using the volume, right? But we're going to be using two formulas. So I'm going to say volume 1. So we're going to call it volume total. Volume total equals volume 1 plus volume 2, right? So the volume 1, we're going to do the volume of the prism. So for the volume of the prism, we know that V1 is going to be base, or B1, times H. All right? So we have B1 is going to be, my base here is 12 times 4, right? As the original was, 12 times 4. So the base is 12 times 4, so it's 12 times 4. And the remaining height here happens to be 11. Okay? 11. So, now that we have this, 12 times 4 is 48. So we have 48, and our units are in inches, so it's inches squared. And then we can say or write that we have 48 times our height, and the height happens to be 11, and that gives me 528 inches or cubic inches, right? So that is volume 1. Volume 2, or V2, still is going to be B2, right? But in this case is half a cylinder, so I need to make an adjustment. Is half a cylinder. So whatever the formula for a cylinder, I'm going to just take half of it. So we actually have, this is going to be 1/2 times pi r squared times h. All right? So we plug those numbers in, and we have 1/2 times pi, our radius is 6, so it's going to be times 6 squared, times h, and h is 4. Okay, we clean this up a little bit. We get 1/2 times 36 pi times 4. Okay, and that gives me 72 pi, and this is 72 pi. We're dealing with volume, and this is 72 pi cubic inches. And then total volume total, actually, yes, volume total. Let me rewrite this. Volume total equals my 528 plus my 72 pi, and we're going to be doing this here to approximately equals 754.1447. And since we're dealing with whole numbers and it doesn't say to round this up to any particular value, this comes out to be approximately equals to 754 cubic inches. And that's the answer for that problem. All right. Moving on to our last example, which is yours to do. It says, find the volume of the composite space figure drawn here. Okay, take a look at it and see if you get the same answer that I do. Good luck. All right. So in this particular space figure, we need to make two other space figures from here. So I'm going to make a little cube, okay, one little cube, and then calculate the other. So we're going to take a look at a cube and a prism. So I'm going to make my best attempt to draw a cube. We can laugh at this a whole lot later. We have this there, there, okay, so we have that cube sort of like that, kind of deformed, but it is a cube nonetheless. Okay, so I'm going to make sure that my dimensions transfer over. I know that the height of this cube is going to be 2 inches. Okay, I know that the width of it is also, the width of the base is also 2 inches. Okay, and its depth happens to be 1 inch, just like it says right here. So this is going to be 1 inch over here. Okay, so we have enough information to calculate the volume of this cubic prism. Then we're going to do the second half of our figure, and let's see if I can come up with something that looks nicer than the first one. Okay, something like this. Something along those lines. And our dimensions here, the base is also going to be 2 by 1. The height, on the other hand, is going to be 4. Okay, notice that if I put these two together to make my original, it comes to be 4, right? 4, so I divided that into 2, so this is why this length is 2, this width rather is 2, this one is 2. Our height here is 4, just like in here, and since this is a cube, it's just going to be 2 over here. It's also not really a cube, it's a rectangular prism over here. It just looks like a cube. Alright, so again, we're just going to say that the volume total equals volume 1, and I'm just going to write it on this other side, of this side here. Volume total equals volume 1 plus volume 2. Okay, so for our first cube here, or for our first prism, we have volume 1 equals, I'm going to go straight for the numbers, which is 2 times 1, which is the area of my base here, times the height, which is 2, and that gives me 2 times 1 is 2, times 2 is 4. So this is going to be 4, and it's going to be 4 cubic inches. So we have that one. So for this one over here, we have volume 2 equals the area of the base, which is a 2 by 1, just like the other one. 2 times 1 times the height, which is 4. So we have 2 times 1, which is 2, times 2 times 4 is 8. So we have 8, and this is going to be 8 cubic inches. Okay, so our total volume is going to be 4 cubic inches plus 8 cubic inches, which gives us 12 cubic inches. And that looks terrible 3. Much better. Alright, and that is our volume for this composite space figure. Alright, and that wraps it up for this lesson. If you have any questions, feel free to send me an email or send me a message through Teams, and I'll be more than happy to help you out. Until then, stay safe, and I'll see you guys on the next one.